Hey team, today we're going to multiply and divide rational expressions. So we'll start with the multiplying first. Let's say we have this problem here of finding the area of a rectangle. But it's not just a friendly rectangle like we're used to. We have a base of x squared minus 36 over x squared plus 5x minus 6, and the length would be x squared minus 3x plus 2 all over x plus 2. Okay, not a friendly rectangle whatsoever. But we do know the area of a rectangle would be base times height. So the area, hey, base times height, length times width, either one. And so, let's take these expressions and plug them into that formula. So we do know the base would be x squared minus 36 all over what they gave us, x squared plus 5x minus 6. And we're going to multiply that with the height, which would be x squared minus 3x plus 2 all over x plus 2. Okay. And so before I just start factoring or distributing and saying x squared times x squared times a negative 3x, and x squared times a 2, and then doing the same thing with the negative 36, I'm gonna look at saying, hey, what does anything have a GCF we could factor out? Does anything factor out? Well, looking at this top one, it looks like we have x squared. That could break down to become x minus 6 times x plus 6 when we factor that. And then let's look at the bottom left. And so what would multiply to negative 6 and add up to negative 5? And I'm thinking of a positive 6, so x plus 6 and a negative 1. And then on the right side, let's see, top right, numerator we have multiplies to 2 and adds up to negative 3. I think we have an x minus 2 and x minus 1. And then x plus 2, we can't really break that down. It's just going to stay as x plus 2. You don't need parentheses. You can put the parentheses around it if you'd like. Okay, so at this point, we factored everything we possibly could. We broke it down. And at this point, it's a good time to list the restrictions. And so what we mean by that is we look in our denominator, and we can't divide by a 0, right? In math, we can't divide by a 0. So if I look at this one, the x minus 1, well, if x was a 1, 1 minus 1 would be 0. That's bad news, because 0 multiplied by anything over here would be 0, which means we're dividing this thing by a 0, and that's not going to work out to us. So x can't be any number it likes to. It has some restrictions. And so, if we start here, x plus 6, well, x can't be negative 6, because that'd make that 0. X can't be a positive 1, like we mentioned right here. And the last one, x can't be a negative 2. So those would be our restrictions, right? And so, x can be anything in the domain, right? You could talk about how left to right the domain. X can't be those 3 numbers, but it could be any other number that it wants. So before we finish this problem, we now have to see what we can simplify, what we can cancel out. And so it looks like in the numerator we have an x plus 6, same in the denominator. So those are going to actually cancel each other out. And since we're multiplying, we can go across here. The x minus 1 and the x minus 1 would cancel each other out. And let's see, this one's close. It's the x minus 2, x plus 2, so they're not the same term. Those will not cancel. So that leaves you with a simplified form of x minus 6 times the quantity of x minus 2 all over x plus 2. And that is your simplified form with your restrictions right there. Okay. Let's take a look at dividing rational expressions. So here we have a problem now. We're dividing rational expressions. So we have, quite the lengthy problem here. We have 6x minus 3x squared over 36 minus x squared divided by all of this. Well, before I decide to do any synthetic division or long division of polynomials, well, I'm going to take a page from grade school and say, let's multiply by the reciprocal. So we actually have 6x minus 3x squared over 36 minus x squared. And we're going to multiply by the reciprocal. We'll simplify things way up. And that means we'll have x cubed minus 5x squared minus 6x in the numerator, and we'll have x cubed minus x squared minus 2x in the denominator. Alright, so just like the last problem, now we instead of multiplying all these together and factoring and distributing, we are going to look for factors in GCF. So in this top left one, it looks like the GCF, we could take a 3 out, and we could also take 1x out of both terms, leaving you with 2 minus x. Okay. And then underneath in the denominator, well, if we look at this one, give me a little room on the left, right here, this would, you could write it out to be negative x squared plus a 36, and then you could take out a negative 1, so it becomes x squared minus 36, and then all of a sudden, oh, now we could factor that, because that becomes x plus 6 and x minus 36. So don't forget about your negative 1 in front. We have x plus 6 and x minus 36. Or excuse me, x minus 6. On the top right, looks like we could take an x out of both terms. So let's see, this one would become x times x squared minus 5x minus 6. Okay. And so now we're thinking, hey, what multiplies to negative 6 and adds up to negative 5? Well, don't forget about the x in front, but that's going to be x minus 6 and x plus 1. And let's look at the denominator there. So this one, again, the GCF would be x, leaving you with x squared minus x minus 2. Okay. And then what multiplies to negative 2 and adds up to negative 1? Well, it looks like that's going to be x minus 2 and x plus 1. Okay, so before we start canceling out, this is a good time to list our restrictions. And so let's take a look at our denominator. So again, we can't divide by a 0, that'd be bad news. So it looks like our first one, x cannot equal a negative 6, x cannot equal a positive 6, x can't equal, let's see what's next. Hey, don't forget about this x right here, that means x can't equal 0. Let's see, x cannot equal a positive 2, and x cannot equal a negative 1. So positive 2 for this one, negative 1 for that one. Okay, so x can be any number in the domain except for these numbers. Those are our restrictions. Alright, let's simplify what we have. So we have x plus 1 cancels x plus 1. X minus 6 cancels x minus 6. Let's see. X cancels x. Okay. And what else do we have? Okay, this 2 minus x and this x minus 2, how would they relate? Well, again, if I were to rewrite this, it'd be a negative x plus a 2. And if I were to take out a negative 1, it'd become x minus 2. And so those are the same terms, so we have a negative 1 here, but these would cancel. And I'd still have that negative 1, so the negative 1 would stay out. And then, looks like we canceled all we can cancel, so that would leave us with a negative 1 times 3x in the numerator, and then a negative 1 times x plus 6 in the denominator. The negative 1s, hey, they also cancel each other out, leaving you with 3x over x plus 6. Alright, and so that would be our simplified version, and with our restrictions, so x could be any number in the domain except for those ones, and that is our simplified result. Okay, and that concludes, hey, dividing and multiplying rational expressions.